Okay, warm up. Find the equation of the line that goes through the point. X coordinate is 3, the y coordinate is 1, and that line has a slope of 2. So how do you find the equation of this line? There's a couple ways of writing down that equation of the line. One of them would be slope-intercept form. That's what you did in algebra 1, y equals mx plus b. We don't use this in calculus. The main one we use is called point-slope form of the equation of a line. So point-slope form of the equation of a line is this. Y minus y1 equals mx minus x1, where now the x1 and y1 will be the given point. So it's x1, y1, and the slope m is going to be what's given here as a slope, and it's 2. So if all we wanted to do is write the equation of a line, you would need a point and a slope, and we're given a point and a slope. So all you got to do is just plug that info in there that's given. So x1 is 3, y1 is 1, and the slope is 2. And with this, you're done. So this equation will describe the line that goes through the point 3,1 and has a slope of 2. So how do we know that this is true and it works all the time? Well, if we go to the graph and we put the point at 3, 2, and we say that the slope is 3, 1, and the slope is 2, then we have on the graph x is this is the x coordinate, this is the y coordinate. So when x is 3, y is 1 would be this point, because the x value is 3, the y value is 1. Then it has a slope of 2. Slope of 2 is called rise over run. So it's how much you go up and then over how much you go over. So rise up, you're rising up 2, and then you're going over 1, 2 over 1. Now, why is this equation true? Even more so that this is always going to satisfy this line at every point. Let's choose any other point on the graph. For example, let's choose this point on the line. And this point is going to be 2 is x, y is negative 1. And if you plug this x and y, now this becomes the variables, into this equation here, then it will satisfy the equation. It would be a true statement. So we plug in x and y, and we plug those numbers in. So we got y is negative 1. You see this one right here is negative 1 minus 1 has to equal to 2 times x is 2 minus 3, and it has to be true. So negative 1 minus 1 is negative 2, and then you have 2 times negative 1. 2 times negative 1 is negative 2 equal negative 2. So this is always going to be true no matter which point you use on the graph, on the line. It would always be true that it satisfies the equation. Now, even more so than this is that what I'm just saying is that the slope is always constant for a line. So a line has a constant slope no matter what point you're looking at. So even if I chose this point here, the slope is still going to be the same between these 2 points. Say I find, let's look at the slope of between these 2 points here. Rise over run is slope. So the slope will be how much are we going up from one to the other. I guess we start on this down here. 1, 2, 3, 4. And then we're going over 1, 2. 4 over 2 is 2. The slope is constant. So the only equation that has a constant rate of change is a line yeah, it would just be a line that it has a constant rate of change. But most things in life don't have, don't go at a constant rate of change. One example is if I draw something here, say I go quadratic, which we're going to go over in a minute. Say this quadratic here, it is no longer a straight line. It is a curve now. So at every point, the rate of change is different. So at this point, it is going, the tangent line would be the slope. So this looks to be a negative slope. Whereas if I chose the point here, this would have a positive slope. Because we go back to the definition of what slope is rise over run. But here, we don't have 2 points for the curve. We only have 1 point, and that is a problem. And also here, we don't have 2 points. We only got 1 point, and that also is a problem. All I know here is that the slope is negative, and all I know here is that the slope is positive. All I know here is that the slope is 0, because the slope, we're not rising up, that's 0, but we're going across as much as we want. But even then, for the tangent line is horizontal. So whenever you got a tangent line that's horizontal, the slope is going to be 0. This is very important to understand, because this is what calculus is about finding rates of change of curves, and no longer just straight lines. Okay, good.